Hello my dear friend, welcome you all to my this new lecture video series on electrical machine. This is for the student who are preparing or who are studying BTech or diploma, and this video series is very helpful to those who are preparing for GATE, SSC, JE, Assistant Executive Engineer exam or university exam, and like PSU exams also. And this video series contain our electrical machine all topic, and in this video we are going to discuss basic of machines. And first we will discuss generator and how it will work, principle of generator, and we will see 2-3 questions on it. So let's start our video. So before starting our video lectures, I want to tell you that if you like the video, please share to your friend and also subscribe to this channel so that you will get immediate notification whenever I will upload a new videos. Okay, so let's start our basic of machines. So what do you mean by machine? Machine, that means something it will do for us. And so in this basic of machines we had now first discuss the generator. What is generator? What is generator? What do you mean generator? So generator means it generated something from something. It will generate something. That means in our electrical terms, if we apply mechanical energy to something, then it will generate electrical energy. Mechanical energy to electrical energy, this conversion process will do generator. So it is a device which converts the applied mechanical energy into electrical energy. That is called generator. And electrical energy will be delivered by in terms of voltage, current, and frequency. Voltage, current multiplied, then it will form power, and power multiplied with time, then it will form energy. So that is called electrical energy. Okay, so there are 3 type of generator in our electrical engineering. That is DC generator, another one is synchronous generator, and another one is induction generator. So here in DC generator, it will operate at a rated voltage with 0 frequency. There is 0 frequency in our DC generator, and it will operate at rated voltage. That means if we design a a generator to produce 220 volt or 100 volt or 60 volt like this, that particular voltage is called the rated voltage. Okay, and what about synchronous generator? Synchronous generator, the voltage and frequency are constant. Okay, the voltage and frequency are always constant, and here the speed of ns is the speed of synchronous generator, that is also constant. Okay, it rotates at a constant speed or constant frequency. Okay, and its cost of power generation is reduced because it rotates at a constant speed. And an induction generator, see, in induction generator, voltage and frequency are variable, and its speed is greater than synchronous speed. Synchronous speed, it is rotate at a constant speed. Okay, and that constant speed is less than our rated speed in induction generator. So in induction generator, the 2 things are what? Those 2 things are variable. So we need 2 things to be constant. We need 2 things to be constant. Okay, so these 2 things are to be constant. So here I have written all the thing. And this is generator, the output is rated voltage with 0 frequency, and the synchronous generator, the output is at constant at voltage and frequency, and the induction generator, the output is at variable voltage and frequency. Let's see the two terms. A synchronous generator is suitable to connect directly to the load, and but not induction generator. Why? Because of synchronous generator is rotate at a particular constant speed. That's why we directly use to the load. Okay, and why not? Because this induction generator will not operate at a particular speed, it will operate at variable speed or greater than synchronous speed. Okay, so we are using induction generator in wind power plant, low speed wind power plant. Okay, and wind power plant will operate at a lower speed. If we generate 100 rpm, then if we put a gearbox on this wind power plant and its gearbox rating is 1:16, then it will produce the output power at 1600 rpm. Okay, so if we use the gearbox, then cost will be also increase. Okay, so let's see some notes. This is very important. And among all the type of generator, induction generator are preferred with more number of poles. Why? Because its speed is less. That's why we are using more number of pole to increase the number of rpm and reduce the size of gearbox. Okay, in order to reduce the size of gearbox, we are using the more number of pole in the induction generator. And the three things you have to remember. This is first, in DC generator it will operate at a unit power factor. Why? Because the voltage and current are in same phase. That's why it is operate in the unit power factors. And in synchronous generator it will operate at all power factor. All power factor means there are two power factor, lagging power factor and another one is leading power factors. So it will operate into both the leading and lagging power factor. Okay, and in induction generator it will operate only in the leading power factor. So here I have mentioned a DC generator always operate at a unit power factors, synchronous generator can operate all power factor, and induction generator only leading power factors. Okay, so now we are going to see the principle of generator, in which principle it will operate, or in which principle it will work to get the electrical energy. Okay, so now our one most important scientist, Faraday made these laws. That's why by the name of the scientist, its rule is known as Faraday law. So whenever a conductor quotes the flux or flux quotes the conductor, this is the three line. These three lines are the flux. Okay, and this rectangular bar is called the conductor, and those are the two magnet, north pole, and this is the south pole, north pole, south pole, and the flux is from the left side to right side, that means north to south. Okay, and this conductor placing slanting, and this is rotate. If we move, if we rotate, then whenever a conductor caught the flux, this conductor cutting the flux or flux caught the conductor, this flux are cutting the conductor. Okay, then an EMF will be induced in the conductor. In this conductor, an EMF, that is electromagnetic force, will be induced in the conductor. This is the principle. Okay, the direction of EMF induced in the conductor can be found out by the Fleming right hand rule. So what is Fleming right hand rule? This is also another scientist named Fleming who made this rule. That's why it called Fleming right hand rule. Okay, so in Fleming right hand rule, in the right hand we place thumb finger, forefinger and middle finger at 90 degree to each others, and then forefinger indicate, this is the forefinger, and forefinger indicate flux, and thumb finger indicate motion of the conductor, and middle finger indicate current or EMF. So shortcutly, this is the M, this is the F, and this is the C. So you have to remember like MFC. Okay, this is motion of the conductor, flux, and the current. Okay, so this thing remember, MFC and Fleming right hand rule, Faraday law. And now we are going to solve one questions, very easy questions, you can easily find out. So for the figures shown below, identify the direction of the current in the conductor 1 and 2. So there is two conductor, this round shape, red color round shape are the conductor. These cross and dot sign are not given. I have here for easily understood, I have mentioned here cross and dot, but this thing in this question it has asked. Okay, and only this direction of the rotation is given and the flux direction given. Direction of rotations means it will rotate in the clockwise direction. Okay, and this north pole to south pole the flux are going. Okay, so if we show the direction of rotations, that means this conductor going upward and this conductor going downward, this is moving of conductor. Okay, so which finger indicate the moving of conductor? Moving of conductor, that is shown by the thumb finger. So thumb finger in upward direction, and which finger indicate the flow of flux or force? This is our forefinger. So forefinger indicate in this direction. Okay, so motion of conductor in this direction, upward direction, and this is the flux direction, and inward direction is our middle finger. So this is in this direction, this is the middle finger. Okay, so it is inward, inside, that means it is cross sign. So cross and inside, that means current flowing inside in this first conductor. Like this here, if we see the conductor is moving downward direction, that means our thumb finger in the downward direction, and flux is going from north to south, that means this direction, forefinger this direction. So our middle finger is in outward direction, that means this direction, and thumb finger this direction. Okay, so it is dot in second conductor, so current is in outward. Okay, so this is our answer. Now let's come to the another questions. For the following figure, the direction of the current in the conductor 1 and 2 is what? So this is the direction of conductor, and it will moving like this in clockwise direction, and this is the south pole and north pole, and here the flowing of flux from the north pole to south pole. So this conductor is placing on the magnetic neutral axis. Whenever the conductor is placing in the magnetic neutral axis, there is no EMF will be generated. That's why zero EMF will be generated in the first and second conductor. So because the conductor not cutting the any flux, that's why it is zero EMF. Okay, so remember another two things. In SC, voltage regulation depends upon the lagging, leading and unity power factor, but in DC case voltage regulation is positive and negative or zero, depend upon the generator DC type. Okay, So same thing I have written here in the note. The axis along which the electromagnetic force induced in the conductor is called is called the magnetic neutral axis. This is the magnetic neutral axis, okay, where electromagnetic force are 0. Now see another questions. A field is rotating around a stationary armature having two coils. Stationary armature having two coils as shown in figure. This is the one coil 1-1 and another coil 2-2. Okay, at this instant shown in the figure, which of the following statement is correct? So first statement is dot in C1, no EMF in C2. Second statement is in cross in C1 and no EMF in C2. So which one is correct? So if we see that conductor is not moving, only on the north pole and south pole magnets are moving. So those magnets are moving in the clockwise direction, and this thing is stationary. The conductor is stationary. So we have already studies that conductor is moving and magnet are stationary. So it is little bit confused to us. That's why I am clarifying to you that if this magnet are moving, then don't consider the moving of magnet, then consider the moving of this conductor in opposite direction to that moving of magnet, and then calculate the dot and cross. So we are considering the opposite direction. That means it is in clockwise direction moving of north pole and south pole, and now we are considering the conductor moving in the opposite direction, that is anti-clockwise directions. Okay, so if we place anti-clockwise direction, then this conductor moving in the upward direction, this conductor moving in the upward direction. So thumb finger is in upward direction, flux is in from north pole to south pole, and the dot will be appear at a outward. That's why dot in C1. If dot in C1, then this first days it will be cross. Okay, so dot in C1, no EMF in C2 because of it is placing on the magnetic neutral axis. Okay, MNA. So let's see another questions. For the figure shown in below, the direction of the current in C1 is, direction of the current in C1 is, this is the C1. So what is that one? Is C1, this is C2. Okay, that is north pole, and the movement of north pole and south pole is given, that is clockwise direction. It is moving in the clockwise direction, and conductor movement is not given, so we are placing opposite direction to this. Okay, so that is anti-clockwise direction, and this conductor, if it is moving in the this direction, then thumb finger will be placing like this direction. Okay, and flux 90 degree to it. So thumb finger, flux, and our middle finger, this is 90 degree to this. That means cross in the C1 and dot in the C2. That's why cross in the C1. Now see another questions. For the figure shown in below, which of the following statement is correct? So there are 4 statement, and there are 6 conductor, and this north pole and south pole magnet are moving in the clockwise direction. That's why we have to consider in the anti-clockwise direction. So like that, this previous case, this is also same, like this conductor will be moving like in opposite direction. If I put like this, then we will find the option A is correct. Okay, you have to do this. So the voltage regulation of DC generator is also positive, negative, zero, which depend upon the type of DC generator. So for today that is. So in the next lectures we are going to discuss the next part, and like flux density, magnetic field intensity, permeability, we have to discuss all those things. And next left out part is right thumb rules, so which we have to discuss. So for today that's it. Thank you for watching. Thank you all.